we want to do one additional lesson to make sure we fully appreciate what the leading coefficient in a parabola tells us about it. Plus, we'll get a bit more work with completing the square, although it will be more challenging. Let's understand what A really does. So far, we know that if A is positive, it will be a happy graph. If it's negative, it will be a side graph. So let's look at our calculator to sketch a graph of y equals x squared, y equals 2x squared, and y equals 4x squared. I'm not going to put screenshots in there today. If you would like to do that on your own, you may, to go through and see what it looks like. But my first graph is going to be y equals x squared. And it's going to be a pretty wide graph. It'll look like this. Then y equals 2x squared. Again, it's going to start at 0, 0, but it's going to look more like this. And my last graph, y equals 4x squared, is going to look more like this. Explain what is happening when we multiply x squared by a. Well, when we multiply x squared by a, it's going to get smaller, or skinnier and skinnier and skinnier. So, the larger a is, the skinnier the graph. So A stretches and compresses a parabola depending on whether it is greater than 1 or between 0 and 1. Sound familiar? Well, this is similar to the base of an exponential function. So the graph below shows the curves that are listed. Write the number of the equation of each beside its curve. So the first thing we're going to look at is number 1. Y equals 3x squared. Well, that one's going to be a positive graph. And our positive graphs are 3, 1/2, and 1. So 3 is going to be the skinniest graph, so this one is 1. Then we need to look at which one's going to be our next skinniest. Well, our next skinniest is going to be the one that's 4. So we've done 4 and 1. So our last positive graph is going to be the widest graph, which is 1/2. Now we're looking at the negatives. Negatives are going to work the same way. The larger the negative number, the skinnier it will be. So the skinniest one is going to be 3, and the other one is going to be 5 because that's -1. So -2 and -1. Since all quadratics of the form ax squared have their turning points at the origin, we can also identify turning points if we can place a quadratic in vertex form even if a doesn't equal 1. So consider this first one. We are going to take the 2 out. And we're left with x squared minus 6x. And we don't know what our c is yet because we're making a perfect square, right? But we still have our plus 11 from up above. Now, we need to figure out what our c is. So, -6 divided by 2 squared is -3 squared. So this is going to be +9, because -3 squared is 9, which means we're going to subtract 18. How did that become 18? What became 18 is we take what our c is and we still have to multiply it by that number on the outside. So we subtract 18 because if I were to re-multiply that 2 in, it would be a plus 18. So now I have 2 times x minus 3 squared minus 7. So what is my turning point going to become? Well, my turning point is still going to be my h, which is 3, and my k, which is -7. The 2 just means it'll be a skinnier graph. kind of confusing. But we'll get there eventually. So obviously 3, -7 is your answer. So let's try this again with a couple more. We're going to take 5 out, and we have x squared plus 4x, and we don't know what the c is yet, but we know that we do still have a plus 23. So 4 over 2 squared becomes 2 squared. So I know that I'm going to have an x plus 2 squared. But 2 squared is 4. I still have to take that 4 and multiply it by the 5, and we're subtracting 20. So plus 3, so my turning point is -2, positive 3. Next one, I'm going to take a -2 out, and I have x squared minus 2x, oops, and something else, plus 7. So -2 over 2 squared is -1 squared, which is 1. So plus 1. And then 1 times -2 is a -2, so we're going to do the opposite of that, which is plus 2. So it becomes x minus 1 squared plus 9. So my turning point is 1, 9. Next one, take a 6 out. We have x squared minus 4x. We still have our plus 14. -4 divided by 2 squared is -2 squared, which is 4. So plus 4. Remember, we have to take that 6 times 4. 6 times 4 is 24. Do the opposite of what it is. Since it's positive, it becomes minus. So I have x minus 2 squared minus 10. So my turning point is 2, -10. And last one, we're taking a -1 out, and we have x squared plus 12x minus 33. So 12 divided by 2 squared is 6 squared. So it's going to be x plus 6 squared. But 6 squared is 36, so this becomes plus 36. Multiply 36 times -1 is -36. Do the opposite, which is another plus 36. So we have plus 3, and it is -6, 3. There's one thing that I forgot to do in all of them. I forgot to include the 5 here, the -2 here, the 6 here, and the -1 here. Those do technically need to be included.